A walkthrough of Problem 1 on Practice Exam 2 of Module 12 in the book Problem Solving Guide for Mechanics and Thermodynamics. An ideal monatomic gas is at a temperature of 400 kelvins. It exerts a pressure of 250,000 newtons per square meter and a volume of 10 liters. It is then heated at constant pressure until the volume is 15 liters. Part A, what is the change in internal energy of the gas? Part B, how much thermal energy was added to produce this change. So let's sketch the initial and final states. Here's state 1, 400 kelvins, 10 liters, 250,000 newtons per square meter. State 2, the pressure is the same. It's heated at constant pressure, but the volume is 15 liters. There we go. We don't know the temperature yet. But if the volume increases by a factor of 1.5 from 10 to 15 at constant pressure, the temperature must go up by a factor of 1.5. So T final must be 600 kelvins. But let's do it. So let's calculate it. We need to know the number of moles. We have PV and T. We can calculate the number of moles with PV is equal to nRT, 0.752 moles. Now we can use that to get the final temperature because now we know N. So the temperature is PV over nR, and we can calculate the final temperature. If we stick in, that's 15 liters right there. So 600 kelvins as expected, and now we can put this on the diagram. So now we have the initial state and the final state. We have to get the change in internal energy of the gas as a result of this process for part A. The internal energy change is 3/2 nR delta T. So if the temperature of 0.752 moles of an ideal monatomic gas is increased by 200 kelvins, the internal energy went up by 1876 joules. Now part B. Probably too many significant digits there, but that's okay. So work is done. We have to calculate the work done. The pressure is the same. The volume went up by 5 liters. So P delta V. So the gas did 1250 joules of work. So two things happened to the gas. When it was expanding, it did 1250 joules of work, and its internal energy went up by 1876. How did it do that? The answer is thermal energy was added. And it did both of those. That's what Q is. The change in internal energy plus the work done by the gas. So you need 3130 joules. And that's the answer to part B, and that's problem 1.